And today we discuss about basic computational structures. But before we start to discuss about it, let me show you several slides about operations that will be useful for you. We didn't consider it on previous lecture, but I think it will be very useful. First of all, let me remind you once again that all of the operations, addition, subtraction, multiplication, can be applied to integer numbers. But if you apply division to integer numbers, remember that the result of the division of two integer numbers is integer. For example, 7/2 equals to 3. And students usually make a lot of mistakes. They forgot that if you write such expression, the result the result will be integer and will contain the integer part of the division. And let me show you the simple example. Plot x equals to 1/3. Let's output the result to the screen. What we see on the screen? What will we see on the screen in this case?
0.3333.
No, this is very hard question. It's not 0.333.
We use a float. You didn't use integer, so
we see 0 on the screen. We will see 0. X equals to 0. Well, now I explain why we see 0. Why not 0.33333?
I think we have to use double to get the result.
The result will be the same, 0. It doesn't depend on the type of x. You can use x equal, you can use float, you can use double. The result will be 0.
We can put it like 1.0.
Yes. The reason that we get 0 is that 1 is considered to be integer 1, and 3 is considered as integer 3. Yes, and to tell the compiler to consider this number as a real number, we should write here 1.0 and 3.0. Please remember it that 1 is integer 1 and 1.0 is a real number that equals to 1. In this case, we can see on the screen 0.333. You can use double, you can use float, any real value type, you will see 33333. Moreover, if you use only one 0.0 here, for example 3.0, the result will be a real number, 0.33333. But if both of the arguments are integers, the result will be integer. If you move your mouse here, Visual Studio tells you that this number is considered as int3 and int1, but the result of this operation will be assigned to float number x. But the result is integer. But if you type 1.0, again, move your mouse here and you see that this 1.0 is a double 1.0 and the result will be double. Double is more powerful type than float, but if we assign double to float, we lose some significant numbers, but we see more or less correct result as 0.33333. Well, is it clear? If you want to make a real division, please write the fractional part, even this part is 0.
Okay.
Well, then the next operation, I already mentioned it, but now let's discuss about it in more details. Person sign. Person sign is a special operation of getting the reminder or module. 7 person signed, 2 is 1. This operation can be applied only for integer numbers. For example, I cannot, if you type here person sign, Visual Studio outputs your mistake of compiler. But if you use here integer numbers, the result will be the reminder of the division. 1 person sign 3, the reminder is 1. 2 person sign 3, the reminder is 2. 3 person sign 3, what will you see on the screen?
Is 0?
0, 0, because 3 can be divided over 3 without reminder. Reminder is 0. And once again, 4 reminder 3, 1, 5 person sign 3, 2, 6 person sign 3, again we have 0, and so on. Well, this is one more special operation that can be applied only for integer numbers. Only for integer numbers. Okay. Well, a few words about operations plus plus and minus minus. I think you already use it on practice. These operations can be applied both for integer numbers and for real numbers too. For example, x plus plus. What we see on the screen?
7.
7. Yes, it's a very simple operation. Plus plus increases their argument. 7. And minus minus, it's 1, decreases.
5.
Yes, of course, 5. And these operations can be applied both for integer numbers, for real numbers. Even this is a real number, something like this, 6.1, and we can apply minus minus. And we see on the screen 5.111. But usually, as a rule, this operation is applied for integer numbers. But it can be applied for real numbers too. And there is one feature of this operation, that plus plus or minus minus, let's consider it with interest, can be applied in so-called prefix form when the sign of operation is written before, or postfix form when the sign of operation is written after. It's also written here in my slides that plus plus or minus minus can be placed before the operand or after it. And if you write this operation as a standalone line, standalone operation, there is no difference between these two options. You can place before, you can place after, it doesn't matter. But the difference, you will see the difference if you use this operation as a part of another complex operation. When you place plus plus before, this addition is carried out before using of the operand in the expression. But if you place plus plus after, this addition or subtraction is carried out after the operation. Here is written some examples, but I think it's better to show you this in Visual Studio. For example, let's declare let it be a equals to 6, and for example b equals to 4. And let me write the expression. Okay, let it be c. B equals to a plus plus 4. You can use operation plus plus and minus minus inside some complex expressions. And what will be the value of c after this operation?
12.
12?
10.
Oh, plus 4. No.
11.
15.
Whoa. 12 or 15
Wait, so
are,
it's plus.
are completely incorrect results.
11.
11 is more correct, but it's also wrong.
It's
What?
10.
Because the result of C will be 10. And A after this operation will be 7. C will be 10, A will be 7. Why? It depends on where you write plus plus. If you write plus plus after, then in this operation, sorry, it should be, of course, B, but in this operation, you will use old value of variable A, and this value will be increased after the operation. Value of A will be 7, but this 7 will be assigned to A after the operation. And inside the operation, old value of A, 6, will be used. And we have 6 plus 4, 10. But if you write plus plus A plus B, in this case, new value of A will be used. New value of A is 7. 7 plus 4 is 11. And we will see 11 and 7 on the screen. You see that in both cases, after the operation, A will be 7. But the result of operation will depend on where you write plus plus, before or after. But let me say again, this is a sum feature. And if you write plus plus as a standalone operation, it doesn't matter where you write plus plus, before or after A. In both cases, after this operation, new value of A will be 7.
What if you do in both before and after? What happens?
What happens?
Yeah, does it increment it twice, or is it just error? Okay, error.
I don't know. I think
Okay.
it will be error, but I think if you write it something like this, A plus 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 plus, I think it will be correct if you write it in brackets.
Okay.
And,
All right, cool.
well, because here, if you write it in brackets, first this plus plus will be applied, and after that this plus plus. In brackets, you can write only also something like, oh no, it will be wrong. Well, but again, please understand me on the right way. This is a features of C. And usually in the most cases, in 99.9% of the cases, it's enough to write plus plus in this style, A plus plus or A minus minus.
Okay.
A plus or plus plus A. Well, okay, and about shift operation we skip it, and very important to understand how to use mathematical functions, because it's used very, very often. And to use mathematical functions, you should write in the beginning of your program, include math point h, and after that you will okay, this is about real types. Well, standard mathematical functions. When you write include math point h, you will get access to very long list of mathematical functions. I show this in the slides, just maybe the most important of these functions. All the trigonometric functions, arc cos, arc sine, and so on, cos, sine, exp, that corresponds to e power x, some special functions like hyperbolic, cosine. I think you will consider maybe later on mathematical analysis. Very important function, EPS and float EPS for module, absolute value. Log, natural logarithm, log 10. Logarithm with radix 10. Floor, rounding down. Floor returns the largest integer value that smaller than x. Max, maximum between two numbers. Very important function power. Power computes x power y, and so on. Lot of
These are not available in CMath?
Yes, yes, yes. Math point h, this library, this module is oriented on C language, and you can type also CMath. This module includes the mathematical functions oriented in using in C++ programs. There are some small differences between math point h and CMath, and from our point of view, from the goal of our lesson, it doesn't matter what module to use, CMath or math point h. It doesn't matter. Well, let me show you some example. Float a, b, c, and let me assign c equals to power a, b. This computes a in the power b, and let's output the result. Yeah, we see the result, and you can use any numbers, functions trigonometric like sine, cosine, but pay your attention that all their arguments should be placed here in radians, not degrees, only radians. And just as example that function sale, it's rounding up, it returns the value, the integer value that is greater, the smallest number, integer number that is greater than current number. And floor returns the greatest integer number which is less or equal than its argument. And in the C language, there is no function of rounding to nearest integer number, but programmers use often for this purpose the function floor x plus 0.5. Indeed, if x is smaller than 0.5, then we get the integer part of x. If x is greater than 0.5, the result will be integer part plus 1. You can use the function floor let's use a here. Floor to round to the nearest number. For example, floor a plus 0.5, 6.1. We see 6 on the screen. But if you write, for example, 6.7, the nearest number, nearest integer number for a will be 7. And we see 7. And there are a lot of constants, mathematical constants that already declared in math.h and that you can use. For example, MP is number pi, ME that equals to number E, and so on. But again, pay your attention that to use these numbers, by default, these numbers are not accessible. To use these numbers, you should write here this line. Define use math science. Pay attention again that to get access to predefined number pi, before include math.h, you should write define use math defines. And after that, this constant will be accessible. And you will see the number pi on the screen. Well, that's all that I want to say about the operations with integer and real numbers. Some features that we don't consider on previous lecture. Any questions about the operations?
No, sir.
Okay, if you don't have questions, let's switch to the next presentation and let's discuss about basic computational structures. Again, I repeat again that you already use these structures on practice. But during lectures, we discuss about these structures in details. We consider some features of these computational structures. Well, if we consider any program written in C language, program consists of statements, and these statements can be considered as bricks for constructing the building of the program. But these bricks it's enough just to have 3 types of bricks to build any algorithm. So all of the variety of the algorithm, any algorithm can be described by means of 3 basic computational structures: sequential structure, selective structure, and loop structure. Such approach is called the paradigm of structural programming. So, and from this point of view, the programming art is like a puzzle. You take the standard constructions, standard structures, and assemble them in a whole program. And this question, how many basic computational structures is enough to describe an algorithm, is not very simple. And when the programming languages many years ago were developed, the scientists think about it, how many different computational structures is enough to describe the algorithm. And it's proved that using these 3 structures, we can describe any algorithm. And the simplest structure is called sequential structure. Of course, you can say that it's obvious that the statements of the program must be executed one after another in sequential order. But this is not true for modern computers and for modern programming, when some statements of the program can be executed in parallel when we write a parallel program. But we consider the simplest case, the sequential programs, and here the structure of the program is sequential. All their statements are executed one after another. It's very simple to write a diagram that explains this structure. All the statements are executed one after another. And if I consider any program written in C or C++, I can say that this is a one sequential structure, one complex statement that corresponds to one sequential structure. All of the lines, all of the statements are executed one after another. But again, let me repeat that this is not true if we consider modern parallel programming techniques. Now let's discuss about the selective structure. If, then, else. This computational structure realizes one of two alternative statements, independent on the result of checking a condition, which has two possible events. These events, these outcomes of the condition, can be denoted as yes, no, true, false, 1, 0, and so on. This structure contains just two branches, only one of which is carried out. The general scheme of their selective structure can be written in the following diagram. First, we check the condition. If the condition is true, statement number 1 is executed. If their answer is no, if the condition is false, statement number 2 is executed. And the general scheme of their if then else structure is written here. If, then, in brackets, we should write some logical expression. After that, statement number 1 with semicolon, else statement number 2 with semicolon. If the result is true, statement number 1 is executed. If the result is false, if the result of this expression is false, statement number 2 is executed. Let me remind you that 0 is considered as a false and not 0. Particular 1 is considered as a true. Let's here on the next slides, I write here several examples, but I think it's better to consider these examples in Visual Studio. Well, again, let's have two numbers. Let it be float, it doesn't matter. If A equals to B, then statement number 1. For example, I can write just a message here, A equals to B. else. It doesn't to be. Well, the general scheme again. Some expression, the result of this expression is interpreted as true or false. If the result is true, this statement is executed. If the result is false, this statement is executed. Let's write here for. Now A equals to B, and we see their message that A equals to B. Well, very, very simple example, but let's write something more complex. For example, if A equals to B, A++, minus minus. In another case, minus minus. And let's output the value of A after their if statement. What we will see on the screen? What will we see on the screen in this case?
5.
5, yeah.
Yes, 5. A equals to B. This condition is true. And we see 5. So the first branch of if is executed. In this case, A not equals to B. What we see on the screen?
3.
3, because the result of this condition is false. Again, I repeat that from the formal point of view, I can write here any expression. Usually, this expression is written as a condition. One condition or combination of several conditions. But from the formal point of view, I can write here any expression. This line is correct. This statement is correct from the point of view of compiler, A plus B. It seems very strange, but it's correct. Can you guess what we will see on the screen now? This or this?
It'll just be 4.
4?
Because you didn't, yeah, I think it's just 4, right?
No, no. 5. The answer will be 5.
Why?
Why? I explain you. It's not exam. On exam, I will ask you about explanation, but now during lectures, I explain you these features. Well, again, I repeat that usually we write here a condition, but from the formal point of view, I can write here any expression, even computational expression. And the result of this expression will be considered as the logical result on the following way. If the result is 0, we consider it as a false. If not 0, it means true. A plus B, in this case,
it's
equals
8.
to 8.
Yes.
8 is not 0. It means that the result is true. If I write here, for example, A minus B, the result will be 0. 0 considered as a false. and a minus minus, and we see 3 on the screen.
Okay.
But again, this feature of if is used very, it's not often. Just maybe 1.1% cases. In any case, in 99.9% cases, you can write here a comparison operation. For example, if something like this, if A greater than B, or A smaller than B, or something like this. Well, one more example. Let's assign something like this, C equals to 5. Now I want to write here a condition that B should be between A and C. So I want to check that if B must be between A and C. How to write such condition here?
You should say B is greater than or equal to A, right? Because you have 2 number 4, so.
No, I want to write it in this ways. No, not greater or equals, but let it be just greater. Okay, A greater than B. And
Another greater sign. I mean, yeah, and B less than C. You put, yes, C.
Like this. No,
yes.
No. I cannot use I cannot use 2 conditions on the following way.
Oh, you use the AND sign. 2
yes,
AND signs.
I should combine it using logical operation. And B greater than A, and at the same time B smaller than C. Yes, right. There is a correct answer in chat. B smaller than C. Okay, and what result we see on the screen in this case? 5 or 3? What branch will be executed, first or second?
Because I'm gonna say 4, because in the end of the day, you said output A, C out A, and neither of those are true. Either
But
A.
I output the value of A, but after this loop, oh sorry, it's not a loop. After this selective structure, these statement must be executed. At least one of these statements must be executed. A cannot be 4. It cannot be 4. It must be 5 or 3.
Then it's 3. Because you said 0 is false and 1 is true.
Yes, right.
Yes.
In this case, what will we have? A smaller than B. Is it true? No.
False.
Because they are equals. A smaller than B is false. That's why I can not compute other comparison, because this part is false. False and something is false. And as a result, we see 3. Okay, let me move here something like, let me assign here b equals to 5 and c equals to 6. Well, now b is between a and c, right? This condition is true. This condition is true. True and true gives us true. And we see 5. Well, this is feature about complex condition. Okay. The next feature is that from the formal point of view, selective structure must include only one statement in a branch. If it's required to perform several statements, it should be organized as a sequential structure, as a one composed statement enclosed in braces. Something like this. So you should write braces. Let's write C equals to A times A, and let's output C to the screen. The same example as in presentation. So if A smaller than B, I assign A square to variable C. Other case, I assign B square variable C and output it to the screen. Wait a minute, it's better to. Okay, let's do it like this. Just compute the square. I just write a different output statements. Here I assign A square to A, new value of A, and B square to B. In this case, for these values, what will we see on the screen, A or B?
We'll
What
see
branch?
We'll see the first branch.
Yes, sure, of course. The first branch, because A smaller than B is true. And we see on the screen 16. We see 16. A equals to 16. Okay. Well, but what happens if I forget to write here braces? Could you guess what happens?
You see both, yeah, I guess, no, I don't know what happens.
Well, of course, because it's hard question, maybe, for you. Well, let me explain. First, I can show you the result. And if A smaller than B, then, of course, we see this. And also we see the message that B equals to 5. Why? Let's explain. According to the general scheme of the if statement, after else, I can write statement number 1 that will be executed if the expression is false. What happens here when I forget to write braces? Only the first line, only this line, will be considered as a statement that belongs to the second branch else. This line will be considered as the next line of the program that will be executed in any case without checking this condition. So in any case, we will see that B equals to something in this line. Because again, to the branch else belongs only the first statement after else. Only the first statement. If we need to write 2 statements, it must be enclosed in braces. Well, and the good style of programming suppose that you will write braces in any case. For 1, for 2, for several statements, just write the braces without to avoid such mistakes. Just write the braces. Okay, let's come back to the slides. Well, and yes, when you write only one statement like this, you can do it without braces. And here, this one statement is ended with a semicolon. But if you write several statements inside braces, the last, this brace, it must be without semicolon. If you write here a semicolon, it will be a mistake. At the end of the if, the semicolon is optional. You can write it, you can write it or not, it doesn't matter. And usually it's not written. Okay, let's move to the next slide. Selective structures can be nested. It means that I can write one selective structure inside another selective structure, and so on. The next selective structure in general can be written inside next if statement, and so on and so on and so on. Let me write the same example in Visual Studio. Maybe I just write something like this. How to compare two numbers? If A smaller than B, let's write A smaller than B, else else, we have two options, A equals to B or A greater than B. So inside else branch, I can write one more if statement. If A greater than B, in this case, let's output to the screen A greater than B. And the last option, A. If A smaller than B, this branch is executed. If A greater than B, we check this condition and this branch is executed. If A is not greater and is not smaller, then it means that A equals to B. If, oops, what happens? Okay. Well, here A is smaller to B. If I write here 5, we see on the screen message A equals to B. Again, to do it, I write if inside if. But let me repeat again that from the point of view of compiler, this complex statement is considered as a one statement. That's why I must enclose it in braces. Okay. Let's move to the next slide. And let's consider so-called shortened selective structure, selective statement. In some cases, in some programs, it's convenient, it's enough to apply the scheme of partial choice. When statement 2 that corresponds to false is empty, it means their action is do nothing. So if the condition is true, their statement number 1 is executed. If the condition is false, do nothing. And this is an example. This is an example of such short selective structure. Let me copy it. I just copy from the presentation here. Okay. Let's output to the screen the values of the variables P and Q. Well, in this program, what will you see on the screen?
We'll see P equals 2 and the Q equals 2.
P equals 2 and Q equals 2. Because
if P is less than Q, which it is, then Z will be assigned to be.
Look to think about the actions that are written here for a minute.
Oh,
initial values of P and Q are 1 and 2, and the final values that we will see after this if.
yes, it's 1. It'll be 1. It's not 2.
1 for what?
Well, okay, so Z will be assigned to 1, and then P will be assigned to Q. So P will be, so it will output P equals 2 and Q equals 1.
Yes, right. These 3 lines corresponds to very, very often used action, changing the values of the variables. Here we change the values of the variables. The initial values are 1 and 2. Final values will be 2 and 1. But if I write here 3, this condition will be false. I skip here the branch else. Branch else is empty. It means that if the condition is false, just does nothing. If does nothing. And the values of the variables will be 3 and 2. I cannot write a condition where the branch yes is skipped. I can skip only the branch no. If according to your algorithm you should skip the branch yes, you should just change the condition. For example, suppose that you should change the values of the variables when the P greater than Q. You should change the condition. In this case, you cannot change the order of branches, but you can change the condition. Okay. Any questions about if?
No, sir.
No.
Okay. Well, the next topic is multiply, selective statement, switch and break. But I think we start to consider it next. We start to discuss about it next week, next lesson. We briefly consider these multiply, selective statement, switch and break. And after that, we discuss about some features of loop statements in C language. Well, now I stop sharing and I stop